In recent years, functional programming has become increasingly popular and many companies are seeking developers who are experienced in this paradigm. Even programming languages that were not originally designed for functional programming, such as Java, JavaScript, and Python, have incorporated functional capabilities. The reason for this shift is that functional programming is believed to lead to better development practices, including producing less buggy code that is more extensible and robust. However, it remains to be seen whether functional programming will become the dominant paradigm in software development, as there are pros and cons to each paradigm.
Imagine that you're working late at night in a program that you need to submit the next morning, but you're stuck trying to fix a bug. The issue seems to be related to a variable called ratio, which keeps changing based on the state of the system being modeled. This situation is frustrating and can make it difficult to find a solution. However, functional programming can offer a solution by allowing you to write the program in a way that does not rely on a mutable state, and therefore avoid the issue that arise from changing variable values.
But what is functional programming?
In computer science, functional programming is a paradigm where programs are constructed by applying and composing functions. In short, it is a paradigm, a way of breaking up the world and putting it back together in code. It involves both how we organize that piece of the world we're modeling and how we organize and structure the code. Let's take a look to some of the principles of FP. The most important aspect of FP is immutability. Something that is immutable cannot be changed after it has been created. This means that any attempt to modify an immutable object will result in the creation of a new object with the desired changes, leaving the original object unchanged. The relationship between immutability and recursion in functional programming arises from the fact that recursion is particularly well suited for working with immutable data structures. Since immutable data cannot be modified, recursive functions can safely create new instances of data structures at each recursive call, preserving referential transparency and avoiding side effects. Does that mean that if a program is written in a functional style and a person's age changes, this change cannot be modeled? Of course not. That would be absurd. There are techniques like efficient copying that allows us to manipulate our code without ever mutating states. FP is all about functions. What we want is the ability to treat functions as first-class citizens. This means we should be able to pass them as function parameters and return them from functions as return values. If we want to square every integer in a list, for example, we shouldn't have to loop through the list and modify each number by squaring it. We should be able simply to directly apply a square function to every element of the list simultaneously. The map function in many languages allows us to do this. It allows us to work at a higher level of abstraction, where that higher level corresponds to a higher order function. Another component of FP is lazy evaluation. This simply means an expression is not evaluated until it is needed. This is not, strictly speaking, necessary for a language to be functional, but often languages that are by nature more functional tend to be lazy. Imagine that you have to create a list of numbers. The catch is that the size of the list isn't explicitly known until runtime. Luckily, Haskell's elegant design empowers us to effortlessly generate an infinite list of numbers while conserving memory and optimizing performance. In Haskell, we can cleverly create an infinite list that contains all the numbers we might ever need, and then selectively extract only the values we desired on demand. This unique capability, known as lazy evaluation, ensures that we don't waste unnecessary memory by storing the entire list at once. With this approach, we can efficiently work with large or even infinite data structures without burdening our system resources. So, in the end, what benefits do we get from functional programming? We said immutability is one of the most important aspects of FP. Having a lot of mutable states in a program results in a lot of bugs. It's simply not easy to keep track of all the changing values. We also strive to use only pure functions, that is, functions that have no side effects and have the property that if you supply the same input, you get the same output. The biggest benefit, however, of writing functional programs is that you will have a much stronger expectation that your programs will be correct. And well, that's it for this first video. I hope you actually learned something new, and here's a small sneak peek about what's coming next. Thank you for joining, please like and subscribe, and we'll see you in the future.